Hey guys, welcome back to Mr. Magic's stats class. This is P4 stats.
Woo! Yeah, here we go. P4, let's do this. All right, so permutations and combinations. Now, every day, if you use your locker the way that God intended you to use it, as opposed to just kick it and open it, you are actually using a permutation. So really, when you guys think about your locker combination, that's mathematically incorrect. Have you ever thought about that? I know, it's crazy, right? So that's why I put it up here, to help you understand the difference between a combination and a permutation. In permutations, the order matters. So think about your locker combination right now in your head. Think about your locker combination in your... Don't say it out loud! Don't say it out loud. Whew. Right? Don't say it out loud. But don't say it out loud, Peter. 529 what? If I were to change those numbers around and try 1529.5, could I get into Peter's locker without punching it and opening it?
No.
Exactly. So the order matters. That's why it should be called a locker permutation. Now, if any order of those three numbers worked for your locker, right? If you change the order and it still worked, then it would be a combination. The order doesn't matter. Yes?
Is it permutation or permutation?
Permutation. Did I misspell it?
Yeah.
Oh, man. Well, I lost all my credibility. Sad. Yeah, but, I mean, I should proofread it. It's permutation. I'm sorry. Might be. I mean, it isn't, but, like, I should be better. Anyway. For you 6 people listening. Permutation. Thanks, Aiden. All right. I love that you did it. You were like, is it supposed to be? You knew what it was supposed to be, but you were like, well, now you know. It is a permutation. All right. Now you know. So let's do an example. All right. There's some room at the bottom here if you want to write it down. All right. You don't have to. You can also just listen and enjoy. All right. But I have an example here of a permutation. All right. And it's an Olympics example. So we have 8 runners. Can we use runners? Everybody go with runners?
Yeah.
Okay. And we want to award gold, silver, and bronze. Okay. So what I want to do is I want to get my 8 runners.
Look at the little guy on the board.
Oh, well, they can't, though. That's the problem. When you do that on a recording, they're like, oh, cool, where's the little guy? And they can't see it.
You can make it.
No, I'm good. Okay, so what shall we name our runners? Someone with an A.
Anna.
Anna.
Gertrude.
With a B.
Gertrude.
Gertrude or Bert? I don't think I know that one, but how do you want to spell it? T-T-A-N-Y or I-T-N-E-Y?
What? T-T-N-E-Y.
Brittany Snow or Britney Spears? Come on, it's a difference.
Oh, Brittany or Brittany.
Yeah, Brittany. You know what? You go for it, Galileo. You got it. What about a C? Carlos. It don't matter. With a D. That was your chance. Didn't want to say my name. No, it's all good now. Too late. P4. I'll delete this recording. The next one, E.
Elizabeth. Okay, that's a long name.
Edgar. It's such a long name. I hate writing. All right, F.
Fred.
Fred? I like Fred. Sure.
Fred's my dad.
Oh, really? Nice.
Well, it's okay.
Nice.
He calls himself.
Well, it is his name. You can choose. And, geez, at 8, 1, 2, 3, 4, 5, 6, need 2 more. Gerard.
What? Gerald.
Gerard. Do I have 8? A, B, C, D. I need 1 more. H.
Y'all go listen to
Henry. There you go. So I wasn't mad when you guys didn't use Catherine. Not cool. Hey, Adriana. What's up? It's with a C. Here you go.
Y'all go straight directly.
I'm sorry? Oh, these are the important questions. February 23rd. Ooh, she might be listening. February 23rd. I listen. September 28th. Okay. I have my 8 runners. Okay? Let's just say, for our purposes of this example, that I'm going to award Anna the gold medal. Gold. Brittany the silver. You're right, I should have used N-E-Y been faster. And Carlos the bronze. Okay. Now, when I had all my runners, before I gave out the gold medal, how many runners are there? 8. So there's 8 available runners. But once Anna receives the gold, she's out, and how many are left? 7. And same idea for bronze, 6. So when the question says, how many permutations are there? You're going to multiply 8 times 7 times 6. And what does that give you? 336? Excellent. Reading is powerful. So there are 336 permutations because the order matters, right? If I say Anna, Brittany, Carlos, is that the same as saying Carlos, Brittany, and Anna? No, because in that scenario, Carlos gets the gold, Brittany still gets the silver, but Anna gets the bronze. So the order matters, right? Those are different things. So that's a permutation. Now, let's come up with a way that we can use a formula for any other permutations in the future. All right? Now, as I wrote this, 8 times 7 times 6, my brain starts thinking about something in math that I know. Have you guys ever heard of a factorial?
Yeah.
You've heard of that? When have you used that? There you go. Nice job, Yesenia. In math, that's usually a good place to use it. All right? Now, if I was doing 8 factorial, which is an exclamation point after the 8, what would I write out? What does that equal to? That's right. That's exactly right. So 8 times 7 times 6 times 5 times 4 times 3 times... Oh, what else? Yeah. Yeah, but it was fun, though. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right? That's a factorial. All right, so whatever the number is before the exclamation point, take that number and multiply every number after it until you get to 1. I know, but do it to the right. So it's like before, but you write it after. Bless you. I'll write it for you like this. So yes, the numbers are less than 8, but write them after 8. Okay? Now, did we end up multiplying 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1? No, we just multiplied 8 times 7 times 6. So I need to get rid of 5 times 4 times 3 times 2 times 1. So I'm going to divide by 5 times 4 times 3 times 2 times 1, which is what? By 5 factorial. Because 5 factorial would be 5 times 4 times 3 times 2 times 1. Yes. 8, like up here. When I have all of my runners, I have 8 runners. So 8 available runners for the gold medal. So I'll put a G on top for gold. After I award someone the gold medal, I only have 7 remaining for the silver. So now there's only 7 left to choose the silver. And so again, same idea for the bronze. That's supposed to be a B. It didn't come out that way. Let's try it. There we go. For the bronze, there's only 6 remaining. So if I had another medal to award, there'd be 5 remaining. Another one after that, there'd be 4 remaining. That's where I get the 8 times 7 times 6. Now I didn't keep going because we're done awarding medals. Okay? Now, this right here is going to give us our answer, 8 factorial divided by 5 factorial. But the way I want you to think about it in terms of a formula is I want you to look at this slide right here. And I'm not going to give you this formula for the quiz. So this is a permutation, and n is your total number of whatever you have. In this case, we have how many runners? 8 runners. And the k is how many you're selecting. How many medals are we awarding? 3. Okay? So if you were to mentally plug this in, you can also look above and see it. You have 8 factorial, the numerator, which we had. Now in the denominator, what did we have on the other slide? What did we divide by? 5 factorial. But to make it so we still use n and k, we do n minus k, which is 8 minus 3, which gives you your 5 factorial. Okay? So that is the formula I want you to use for permutations. And on the quiz, I want to see what I just squared. Okay? Before you give me an answer. I will show you later in the week how your yellow calculators can do this for you. But I want you to get some practice with factorials first.
K is...
How many you select out of your total number of options. In this case, we had 8 runners, and we're awarding 3 gold medals. So I don't know why I said gold medal, sorry. 3 medals, a gold, silver, bronze. Yeah.
And it's basically like the number 5.
The n actually, it should not have any 5 at all. The n is 8, and the k is 3. You'll notice when we subtract those, that's how we got 5 in the denominator.
Wait, so what is
N is 8. 8 runners.
what does that mean?
It means how many total options do I have to choose from. So I have 8 that I'm choosing from. And how many am I choosing? I'm choosing 3 of them. That make sense? Okay. Any questions on permutations? The key thing for permutations is to think the order matters.
So K is...
Sorry, I should write it. 3.
What is the 3 meaning?
It means you're selecting 3.
Oh, it's like the one that you selected.
Exactly. Anna, Brittany, and Carlos. So if we had done a similar scenario, we had 8 runners, but we're selecting 5 of them to give medals, then my K turns to 5. Okay. All right. Let's talk about how this is different when you look at combinations. All right. So in combinations, the key thing here is the order doesn't matter. Okay. So I've tried to give a similar scenario. All right. But I kind of want to do that same idea about the medals. But just say that the order doesn't matter. So like gold, silver, bronze, in your brain, gold matters the most. That's the most important. That's the person who gets first. All right, silver second, bronze third. But let's just say they don't matter. Okay, so we have all of our runners again. Okay, all of our runners again. But this time, let's think about, we had Anna, Brittany, and Carlos. Now, to make this a little easier, I'm just going to use A, B, and C for those people. Is everybody good with that? What is another order of Anna, Brittany, and Carlos? Because now when I award these 3 medals, I'm saying the order doesn't matter. The fact that I wrote Anna's name first doesn't mean that her medal is more important than Carlos's. So what's another order I could write?
Brittany, Carlos, Anna.
Brittany, Carlos, Anna.
Carlos, Brittany.
Carlos, Brittany, Anna.
Carlos,
Anna, Carlos, Brittany.
Carlos, Anna.
Ah, cab. Oh, back. Any others? That's 1, 2, 3, 4, 5, 6. There could be 3 more. What are the other ones? Anna, Brittany, Carlos, got you.
I know Carlos, Brittany.
Anna, Carlos, Brittany, got you.
I don't think so.
That's it. I mean, you guys really don't believe yourselves. But that's it. There's only 6.
But
You ready for your mind to be blown? You ready? Okay. How many do we have here?
3.
3. What's 3 factorial?
3, 2, 4. 6.
That's
Oh.
So, the reason I bring this up is because now, do you remember our original number, 336? That's how many permutations. But that meant each time I did this, these were all counted as unique orders, right? Gold, silver, bronze. Gold, silver, bronze. They're all different. But when I do a combination, are any of these different? No. None of them are different. Because the order doesn't matter. Okay? So that means I need to divide out the redundancies. Divide by 6. And that would give us the number of combinations. And I just told you we're going to divide out 3 factorial. So one way that students think about this is a combination is just a permutation where you divide out the redundancies. That's one way you can think of it. All right, let me show you the formula we're going to use. Now, I want you to see, everyone can look up here and see, n factorial over n minus k factorial. Do you see how that is the same thing we just used? But there's one more thing that's here that was not in with the permutations. Do you see this k factorial in the denominator? That is the dividing out of the redundancies. Okay? So that's the only difference between the two. So it's really hard when there's only a slight difference to know which formula to choose. So you must ask yourself first, is this a combination or is this a permutation? Permutation is when the order matters. Combination, order does not matter. Okay? So to help your brain figure this out, we're going to do some examples together first. Any questions about permutations and combinations so far? Get ready for your outro. Not yet. All right, so I put this little summary here for you. And yeah, I spelled permutation correct. Sorry about that. Please like and subscribe, even though I can't spell. All right. All right.
All right, guys. Thanks for watching Mr. Brandrick's channel of P4 stats, permutations, and combinations.
Woo!